Good afternoon. My name is Kaius Pollard. I will be presenting my individual contribution to MNG 5137, also known as Mechanical System Design. And for reference, for MS1, I was tasked with printing out the 3D parts for our robot, or the first base initial parts for the robot. MS2, I was tasked with helping with measurements, quality control, helping the programming team learn additional information about coding the robot and learning the loop commands. And for MS, the second half of MS2, I was in charge of making the new MIT App Inventor button, which I'll be discussing in this PowerPoint presentation. And for MS3, I was in charge of assisting in the build of the PowerPoint and things of that nature. And so let me get into this app right here. These are the parts that I printed for the robot. These are just some of the few parts of the 44 pieces that were in total printed for the bipedal robot. Some more pieces. This right here shows the interface for the MIT App Inventor. This shows the title of the control, well, title of the app in reference to an Android phone. You have Connect Bluetooth, which will connect the app to the Arduino Nano that was inside the robot. This right here are the 8 directions that the robot can move in, which will be front, back, left, right, and diagonal directions. These were per specifications by Dr. Choi that he wanted our robot to move in these specific orientations at the bare minimum. This right here is the actual block code itself, and I'll go about explaining it. The code itself is pretty straightforward. I had it basically picked from the list picker, which basically causes it to pick from the list of all the objects on the screen, connected to the Bluetooth client, which is that blue button on the page, which is select the list clicker, which is where all the buttons are. And for each movement, so for forward, I had it connected to button 2, and I also had a stop command also with each of these. So when you press the forward button, you press it, it'll cause the robot to move forward. But once you let your finger off and it stops, it's gonna literally once you take your finger off, the robot's gonna come to a complete stop. That's what this touch up button is for. So once you press down on the button, the forward button is gonna move forward, but once you move your finger off the touch up button, it's gonna stop the robot entirely. And this command was repeated all the way through for all 8 orientations, along with the stop button itself. So the stop button itself also had a stop down, but it'd only be a stop down because once I click it once, I want it to stop. This just shows the rest of the code that we had. This is all of the lines of code for the left back diagonal and right back diagonal. This in particular is the left, and I know that it's probably very blurry on your end, but here you can see the orientation for all of the legs and joints. Here I have it at 180 but just explaining all of this, all this is just the left leg to move back in the diagonal pattern. So if it's moving to the right diagonal, moving back like this, or a better demonstration would be if the robot's standing still, it'll move like this. And if it's moving to the left, it'll literally just, those are the 2 directions that I primarily programmed. And this is those in paper that I've just written up with a script that we had found on Google. Here is the other one, but that's just for the left leg. And so in conclusion, while I was able to come up with the code for the MIT App Inventor, we had a lot of coding issues and a lot of hardware issues that enabled us to actually connect the app to the robot so that we can see the robot move or use the app in that regard. So I feel like if there was anything else that needs to be done, was we just focus less. We explore more coding options to make it a little bit easier on ourselves, so when we get to coding the robot, it won't be so difficult for us to actually implement the MIT App Inventor that we had created, because the app itself had already been created. It was the fact that we just had a whole lot of hardware and coding issues that stopped us from actually using that app to control the robot itself. Thank you for watching my presentation. It's been a fantastic 5 weeks. I'd like to give a shout out to you, specifically Dr. Choi. Thank you for the class. I learned a lot. This class was great, and yeah, thank you.